Molarity. So what is molarity? In its simplest terms, molarity is simply the molar concentration or the number of moles of solute in a given volume of solution, almost always measured in moles per liter. For example, an easy simple equation would be 1 mole per 1 liter of solution is 1 molar, 2 moles per 1 liter of solution is 2 molar, and 1 moles of solution per 2 liters, 1 over 2, it's going to be 0.5. And it's generally represented with N equals N, which is the number, the amount of moles in the solute over the overall volume of solution. So that's the solute plus the solvent. The solute is generally what is dissolved in the solvent. It usually tends to be less in mass, where the solvent is what's dissolving the solute tends to be greater in mass. And the solution is the mixture of the two, with the solute being dissolved in the solvent. And so another way of thinking of molar concentration is the number of moles of solute for every 1 liter of solution, keeping in mind that the solution includes both solute and solvent. So the easiest way to honestly understand it is to just do practice problems. So I got some up here. A 600 milliliter solution of NaCl is diluted to 2 liters with an initial molarity of 0.50 m. And we're supposed to find the new molarity of the new solution. So anytime you're trying to figure out dilution or concentration for molarity, we're going to use this equation, which is M1 times V1 equals M2 times V2. This being the number of moles in the first solution, the volume of the first solution, number of moles in the second solution, and the number or the volume in the second solution. So in this first question, it's asking us to find the new molarity in the second solution. So what we're going to do is we're going to solve for M2, and we're just going to move V2 over to the other side. I rewrote it like this, and then we just plug in. So I've got 0.50 molarity and a 0.6 liter solution, because remember 600 milliliters is 0.6 liters. You actually don't have to convert for this part of the problem, but you're going to need to convert near the end, so you might as well just convert now. We're going to multiply these two and then divide it by 2 liters, and that gives us a 0.15 molarity, and that's equal to M2. Now, the second problem is what volume of 0.1 molar salt solution can be made from 20 milligrams of a 0.75 molar salt solution. So again, we refer back to M1 V1 equals M2 V2, and this time we're trying to find the second volume that can be made from. So it's going to be V2 equals M1 times V1 over M2. And then again, we just plug in. So I got 0.75 molar solution times 20 milligrams, or 20 thousandths of a liter, which is what I got here. And then we divide that by the solution that we're trying to make, which is 0.1 molar. And that gives us 0.15 liters, or 150 milliliters. Now, what volume of 5 molar salt solution is required for 5 liters at 2 molar concentration? So I'm looking for the initial volume, so I'm solving for V1, and I'm going to move M1 to the other side. So I got V1 equals M2 over V2 over M1, and then I just plug in again. So I got 2 molar solution at 5 liters, and we're going to divide that by our initial molar concentration, which is 5m. That gives us 2 liters, so we're going to need 2 liters of this concentrated solution mixed with water, 3 liters of water, and that should give us this concentration right here. What is the molarity of a 1 liter solution with 50 grams of NaCl dissolved in it? Now, with these ones, there needs to be a little bit of conversion. So generally what you need to find is you need to find the number of moles you have. And that's what I have set up in this first part. So I have the initial weight divided by the atomic weight. That gives us the number of moles. And then you would divide it by the number of liters. In this case, it's just 1, so it tends to be kind of easy. And I end up with a 1.41 molar solution. Now, if I doubled this, the liters, I would have half of this. And if I tripled this, I'd have a third of this. Just something to keep in mind. And that tends to be pretty much it. It's kind of a basic concept. There's different ways to plug in and play with the math. But at its core, it's just a measurement or a way of finding the number of molecules in a given volume of solution. So I hope you learned a lot today with Professor Malachi, and I hope you have a wonderful rest of your day. Thank you.